A car engine is the heart of your vehicle, the essential component that makes everything else work. Without it, your car would be nothing more than a stationary object, unable to move or perform its basic function. The engine's main job is converting fuel into the force that moves your car forward, turning chemical energy into mechanical energy. It does this through a series of rapid, controlled explosions inside the engine, a process called internal combustion. These tiny explosions happen in the cylinders, creating bursts of energy that drive the pistons. Unlike old steam engines that burned fuel outside, internal combustion engines burn fuel inside, making them compact and powerful. This innovation allowed cars to become smaller, faster, and more efficient. Imagine a bicycle pump, except instead of you pushing the handle, the engine uses those explosions to push pistons up and down, creating power with every movement. Multiple pistons work together in perfect harmony, delivering a smooth, continuous force whenever you press the accelerator, ensuring your ride is both powerful and steady. Without the engine, a car is just a shell. It's the engine that brings it to life, transforming it from a simple frame into a dynamic machine. Understanding how fuel turns into motion is the first step to appreciating your car's engineering and the incredible science behind every drive. The engine is the prime mover, the central character in your car's story, responsible for every journey you take. It's a marvel of human ingenuity, designed for one purpose, to generate motion and power the adventures that await you on the road. Let's meet the engine's key players, the essential parts that work together to bring your car to life. The cylinder is where the action happens. Most cars have 4, 6, or 8. Each cylinder acts as a miniature powerhouse, setting the stage for controlled explosions that generate energy. Inside each cylinder, a piston moves up and down, transferring energy from those tiny explosions to the rest of the engine. The piston's rapid movement is what keeps the engine running smoothly and efficiently. At the top, the spark plug ignites the fuel-air mixture, while intake and exhaust valves control what enters and exits. These valves open and close at precise moments, allowing fresh air in and letting exhaust gases out. The fuel injector sprays a fine mist of gasoline, ensuring efficient burning. This mist mixes perfectly with air, creating the ideal conditions for combustion. All these parts work in perfect timing, managed by the car's computer and a system of gears and belts. Timing is everything. If just one part is off, the engine's performance suffers. Pistons connect to the crankshaft via connecting rods. These rods act as sturdy bridges, channeling the piston's force to the crankshaft below. As pistons move, they turn the crankshaft, converting up and down motion into rotation. This is the crucial step that transforms energy into usable power. This rotation is what ultimately turns your car's wheels, sending you down the road. The crankshaft is like bicycle pedals, turning straight pushes into spinning motion. It's a clever mechanical solution that's been refined over decades. Every component must work together precisely, or the engine won't run smoothly. Even the smallest misstep can throw off the entire process. That's the brilliance behind every engine's design, a symphony of parts, perfectly coordinated to deliver power, efficiency, and reliability every time you turn the key. Most car engines use a 4-stroke cycle, a process that repeats over and over to keep your vehicle moving smoothly down the road. These 4 strokes happen incredibly fast, repeating thousands of times per minute, creating the rhythm that powers your car. The first stroke is intake. Here the piston moves down inside the cylinder, the intake valve opens wide, and a carefully measured fuel-air mixture rushes in to fill the space. Next comes compression. The piston moves back up, squeezing the fuel-air mixture tightly with both valves closed, packing it into a much smaller volume. Compressing the mixture like this is crucial. It makes the upcoming explosion from ignition much more powerful and efficient. The amount of compression, known as the compression ratio, plays a big role in determining both the engine's power and its fuel efficiency. Higher compression ratios mean more power can be generated, but they also require higher octane fuel to prevent knocking and ensure smooth operation. At the very top of the compression stroke, the piston pauses for a split second. The mixture is now primed and perfectly positioned for ignition. Intake and compression are the essential first acts, setting the stage for the explosive power stroke that follows. While these strokes don't create power themselves, they're absolutely vital for everything that comes next in the engine's cycle. With the mixture compressed and ready, the engine is now perfectly set for the main event, ignition. where all the preparation pays off. The third stroke is the power stroke, the moment the engine creates force. The spark plug ignites the compressed mixture, causing a controlled explosion that drives the piston down. This push turns the crankshaft, generating the torque that moves your car. In multi-cylinder engines, power strokes are staggered for smooth, continuous motion. After the power stroke, the piston is at the bottom, and burnt gases fill the cylinder. The fourth stroke, exhaust, begins. The exhaust valve opens and the piston pushes out the gases. Once cleared, the cycle starts again with the intake stroke. This four-stroke sequence repeats hundreds of times per second. It's a perfectly timed mechanical dance, turning fuel into motion. The sound of your engine is this cycle in action. The engine's spinning crankshaft is just the start. The drivetrain transfers this power to the wheels. First stop, the transmission, which changes gear ratios to balance torque and speed. Low gears help you start moving. High gears let you cruise efficiently. Power travels through the drive shaft to the differential, which splits it between the wheels and lets them turn at different speeds. Pressing the accelerator increases fuel and air, making explosions stronger and the car faster. Easing off slows everything down. This system gives you precise control over your car's speed. Next time you drive, remember, every journey is powered by a symphony of controlled explosions under the hood.